Alright class, welcome back. This is the second video in the series of factoring polynomials, which covers sections 5.5 to 5.7 in the specific book that we're using. Okay, but the subject matter or the content here is how to factor four-term polynomials. So remember that our first step is always going to be to check to see if all of the terms have a GCF. Then I'm going to count the number of terms, and when I count the number of terms, that's going to tell me what method I'm using. So for any four-term polynomial, after I've factored out a GCF, I'm going to factor by grouping. So let's talk about factor by grouping, but let's first follow the first step and look through all four of these numbers to see if there's a GCF. 20 and 15 have a 5 in common. 20 and 4 have a 4 in common, but there's no common factor between all of these. So again, always do my first step. Now I'm going to count the number of terms. I've got 1, 2, 3, 4 terms. Again, terms are separated by addition and subtraction. Okay, so since this is a four-term polynomial, the method that we're going to use is factor by grouping. The steps for factoring by grouping is to group the first two terms and group the second two terms. Okay, what do I mean by group them? Well, now instead of looking at all of them, I'm going to say this is a group, the first two terms, and this is a group, the second two terms. Okay, so I'm going to group these terms, and then after I group these terms, I'm going to identify the GCF of the first group. Okay, identify the GCF of the first group. So looking at just the first two terms, the greatest common factor is going to be 5. That'll go evenly into 20 and 15. And there's also an x that they share. Okay, and remember that when we factor out the GCF, then I need to say what's left. When I divide 20xy by 5x, I'm going to get 4y. When I divide negative 15x by 5x, I'm going to get negative 3. Okay, when I'm looking at these next two terms, my next step is going to be to factor out the GCF. So I'm not just going to identify it, I'm going to say factor out. Factor out the GCF of the first group. Okay, second or third step is to factor out the GCF of the second group. Great. Okay, so now I'm going to look at the second group and I'm going to do the exact same steps that we just did. So negative 4y and 3, they have nothing in common, literally. So because this right here is now in this group, this is my leading coefficient. I have a negative leading coefficient. That makes this sign right here negative. Remember that anytime I have something, I have one of it, so I can just put a 1 right here because there is no common factor other than 1. Remember, if there's not a GCF, the GCF is 1. So when I factor out a negative 1, or if I divided negative 4y by negative 1, I would get a 4y. And if I divided 3 by negative 1, I would get a negative 3. Now that I've gotten the GCF out of both groups, now I'm going to factor out the two-term GCF. Well, this is the two-term GCF that I see both of these terms have. They both have a 4y minus 3. Okay, now I need to talk about then what's left. Okay, well remember, if I divided this by 4y minus 3, which is what the GCF is doing, this would cancel and I'd be left with 5x. And if I divide this term by 4y minus 3, those cancel and I have a negative 1 left. So this right here is factored completely, and this is how we factor, and the steps for factoring four-term polynomials. Again, this method is called factor by grouping. We use this method when we have four terms. Some people use this method when you have 3 terms as well, but I don't teach that method. So when we have 4-term polynomials, we use factor by grouping. Okay, so how about this next problem here? Another example. We're going to say, is there a GCF between all of these numbers? So I'm going to look at x cubed, 3x squared, 4x, and 12. Well, they don't all have a common factor because this one doesn't have an x and this one doesn't have a constant. So there's no GCF. Now that I've done step 1, now I'm going to count the number of terms. There's 1, 2, 3, 4 terms. So I know that I'm going to factor by grouping. That means I'm going to group the first 2 together and the last 2 together. That's kind of hard to see that. That is a squared right there. Okay. So when I group the first 2, I'm going to factor out the GCF of the first group. When I'm looking at x cubed and 3x squared, what they have in common is x squared. When I divide x cubed by x squared, I have an x left. When I divide 3x squared by x squared, I just get 3. Okay, so I factored out the GCF of the first group. Now I'm going to factor out the GCF of the second group. So I'm going to look here and say 4 and 12. Well, what do they have in common? Well, they're going to have a positive 4. And it's going to be a positive 4 because this coefficient right here is positive. This sign is going to match this sign. Okay, so if I divided this by 4, then I would have just an x left. And if I divided this by 4, I would have 3 left. And that's great because now when I'm looking at this, I'm going to say, well, what about the 2-term GCF? What do these have in common? You can see that they both have an x plus 3. And when you're writing what's left, you're literally going to have the coefficient right here, the x squared, and the plus 4. That's because you're dividing out x plus 3 when you pull out this GCF. Now a lot of people are like, hold on, don't you have 2 of those though? No, I don't have 2 of them. Just like when I factored the 5x out of here, I didn't write 5x twice. Yes, there were 2 5x's in here, but when I divided it out, I divided it out of both. Same thing here. If this is the GCF, I divide it out of both, and I only have one of them. I'm not going to write x plus 3, x plus 3. There's just one of them. Okay, let's do 2 more for the practice. Let's say I have 28 x squared y plus a 14 x y squared minus a 70 xy and minus a 35 y squared. Okay, so what I'm going to do, when I see something like this, I'm going to look through and I'm going to first factor out the GCF. Again, the GCF is what is in common between all of the terms, no matter how many there are when you're initially given this. Okay, so when I am looking through this, I'm going to look at 28, 14, 70, and 35. Well, I know my times tables of 7, and I know that 7 times 4 is 28, 7 times 2 is 14, 7 times 10 is 70, and 7 times 35 is 7. So I know they have a common factor of 7. Now, I'm not sure that this is the GCF, but the only other possible factor is 2, because this factors to 2 and 7, and it can't share more than that. It does share a 2 with this one and a 2 with this one, but 35 is 5 times 7. So the only common factor that they share is the 7. Okay. When I'm looking at the constants, it's just 7, but when I'm going to look at the variables, this has x squared and x, but no x here. I've got a y, y squared, y, y squared. Okay, that means that they all have a y. This one has a y, this one has a y, this one has a y, and this one has a y. So I can pull out a y. When I factor out this 7y, that's as if I'm dividing 28 x squared y by 7y. That's going to give me 4x squared. When I divide 14xy squared by 7y, I'm going to get 2xy. When I divide negative 70 by 7, I'm going to get a negative 10. The y's will cancel, and I'll just have x. And when I divide negative 35 by 7, I'm going to get negative 5, and 1 of the y's will cancel. So this is what I have left. Now, if you have a GCF to begin with, which we do here, this is my GCF, then now I'm going to count the number of terms. When I count the number of terms, I'm talking about the number of terms inside of here. Okay, so I'm going to count these terms. I'm going to say there's 1, 2, 3, 4 terms. So I exclude my GCF when I'm counting terms. Because the GCF is multiplied, related through multiplication, it doesn't count as a separate term. And you can see that here, there's 1, 2, 3, 4 terms. Okay, so we've got 4-term polynomial. So I'm going to factor by grouping. And I'm going to do that, I'm going to use a different color here just so we can see what's going on. I'm going to group the first 2 and the second 2, and then say what do the first 2 have in common. Again, the 7y, I'm just going to leave the GCF alone. Inside of this parenthesis, what's in common in the first 2 is a 2 and an x. And what's left, if I divide 4x squared by 2x, is a 2x. And what's left here is a plus y. Sweet. Okay, now I'm going to look here and say, what do these have in common? Well, they both have 5 in common, but it's not just 5, it's going to be negative 5, because this coefficient right here is negative. So I have to factor out a negative 5. And when I do that, when I divide a negative 10x by a negative 5, I get 2x. And when I divide a negative 5y by negative 5, then I get just a y. Now I'm going to look at these two terms, and I'm going to say, oh, yeah, they both have a 2x plus y in common. And what is left here is a 2x minus 5. That was really sloppy. When I divide out the 2x plus y, what's left right here is 2x, and what's left right here is a minus 5. So this is factored completely, but I also have to include my GCF in the factor completely. Okay, so this is factored completely. I want to give one more example here in this section on 4-term polynomials. So all of these, obviously we could do all of these steps and we could factor these. This one had a GCF as well. So what would another possibility be? Well, if I had, let's do, I don't know, let's say 12 x to the third minus 6x squared plus an 18 y squared minus 36 y. Okay, so say like this is my initial problem. I'm going to look and say, always first step when I'm factoring polynomials, I'm going to say, is there a GCF in common between all of these? So I look at 12, I look at 6, I look at 18 and 36. 6 goes into 6, 6 goes into 12, 6 goes into 18, and it goes into 36. So this has to be my GCF. Looking here, these have x's and those have y's, so there's no common factor between all four. So when I factor out this 6, I'm going to get a 2x cubed minus an x squared plus a 3y squared minus 6y. Now I'm going to look inside of here. I'm going to count the terms 1, 2, 3, 4 and say, oh, this is a 4-term polynomial. I should try factoring by grouping. So I'm going to group here and group here. And I'm going to say, oh, first two terms have an x squared in common. And that's going to leave me with 2x minus 1. When I divide this by x squared, I get 2x. When I divide this by x squared, I get minus 1. Hey, and these two, they have a 3y. So I'm going to say plus 3. And I'm going to, plus a 3y. And I'm going to get a y minus 2. And then when I look at this, I'm like, wait a minute. These do not match. And that is true. So I cannot complete this factor by grouping. This is not prime. Some people would be like, oh my gosh, if I can't factor a 4-term polynomial by grouping, then it's prime. But it's not prime because we did factor. Because we factored out this 6, this is not a prime polynomial. So what would the answer be? Well, the answer would just be this 6 times the 2x cubed minus x squared plus the 3y squared minus 6y. And this is factored completely. It can't be factored any further because these don't match, so can't factor by grouping. And I can't rearrange them to make them match. Like this has an x and this has a y. You know, shuffling these terms around wouldn't change that. So this is factored completely, and here's how you would answer that. So in some cases, you might only have a GCF, so be aware of that. Okay, and this is how to factor 4-term polynomials.